Guys, so please note down problem. Note cheyandi. A closely coiled helical spring made out of 10 mm diameter steel rod has 10 complete coils, each of mean diameter 80 mm. Calculate stress induced in the section. Calculate stress induced in the section of the rod. The deflection under the pull and the amount of energy stored in the spring during the extension if it is subjected to an axial pull of 200 Newton. Take modulus of rigidity as 0.84 into 10 power 5 Newton per mm square. Okay, 10 power 5. Please note down. Okay, a closed coil helical spring made up of 10 mm diameter steel rod has 10 complete coils, each of mean diameter 80 mm. Calculate stress induced in the section of the rod, the deflection under the pull, and the amount of energy stored in the spring during the extension if it is subjected to an axial pull of 200 Newton, and take modulus of rigidity as 0.84 into 10 power 5 Newton per mm square. Okay, noted. Come on, note chesara.
Yes, sir.
Yeah. So shall I start? Okay, right. So now, let me draw the diagram first at right hand side. So by that we can able to denote all notations over here. Okay, so this is the spring and this is the axis of the spring. Okay, right. A.M.I.E Vicharama, can anyone tell me the given data? First one, a closed coil helical spring made up of 10 mm diameter steel. What do you mean that?
Diameter of the coil, sir.
diameter of the coil. Ante diameter of the wire anacha?
No, sir.
No. Wire anna coil anna okate. Helical spring, coiled helical spring. I'm not talking about the diameter of the spring. I'm talking about the diameter of the wire. Okay. Wire can also be called as a coil. Okay. And the shear diameter 10 mm. Okay. Right. Next. And it has 10 complete coils. What do you mean that? See, this closed coil helical spring has 10 complete coils under. Ante? What do you mean that? Has 10 complete coils. Ante enti?
Number of rotations, sir.
Very good. Number of turns. How many turns it have? N is equal to 10. Okay. Okay. So this distance is called pitch. N is equal to number of turns. Okay. Right. Next. What is the next given? Each of mean diameter of 80 mm. So the coil is having a mean diameter of 80 mm. What is the mean diameter? What do you mean mean diameter? So this is mean diameter. How much? Then what will be the radius? Correct? Okay. And next, calculate stress induced in the section of the rod, the deflection under the pull, and the amount of energy stored in the spring during the extension if it is subjected to an axial pull of 200 kilonewton. So that means the spring is subjected to pull of how much? 200 Newton. It is not push. Okay, so there is a pull, and they given N as 0.84 into 10 power 5 Newton per mm square. Okay, and the load is given as 200 Newton, and the number of turns are given as 10. Diameter of the wire is given as 10 mm dia. Radius of the coil is given as 40 mm. And then, so this is the data given, right? Isn't it? So load can be written as even W or P. P anna raichu, W anna raichu, no issue. Okay. So now first we will try to calculate the torsion of the spring. Torsion. What is the torsion formula? W into R. Okay. What is W? 200. And what is R? Radius of the coil 40, which is 8000 Newton into mm. Right? And next, what is the next one? We have to calculate torque, okay, based on the shear stress, isn't it? So because torque was calculated, but he is asking us to calculate the shear stress which is developed due to torsion, shear stress which is developed due to axial load. Why? Because here you need to observe there are two things going to happen. When it is subjected to pull, your spring will be subjected to torsion, it will be subjected to axial tension, right? So two things are happening over here, right? So from torsion we have calculate torque, From this torque, you are going to calculate the torsional shear stress. Can anyone tell me what is the formula for the torsional shear stress from the torque equation? ఎవరైనా చెప్తారమ్మా? T by J is equal to tau by R, right? So then write down tau is equal to T into R by J. It can be written as finally T into 16 by pi into d cube. Right, Cha? Right, Cha? Final ga ela rasani cheppandi idi? Ela rasani?
Moment of inertia.
Yeah, very good. So because J is nothing but polar moment of inertia of the circle is pi d power, pi d cube by enta
32, sir.
Yes. So based on that, you can able to calculate the shear stress. Tau is equal to T into 16 by pi d cube ga raichu. Why? Because this radius can be written as 2 times of the dia, and polar moment of inertia can be written as pi d power formula raichu, lekapothe R formula kuda raichu. Okay. From this, you need to calculate tau. Calculate what is the shear stress based on the torsion. What is torque, amma? 8000 into 16 by pi into what is the diameter of the wire? Here D stands for what? Diameter of the wire. What is the diameter of the wire, amma? 10 cube. See, don't get confused, because you people may get confused in deciding the diameter of the wire and diameter of the coil. Okay. So diameter of the coil is 80 mm. So which always represents as the diameter of the coil. For this, we are going to use radius. Okay. R stands for radius of the coil, and here small d stands for diameter of the wire, because J is nothing but polar moment of inertia of the wire in the spring. Okay. So don't get confused. So ikkada J anedi enti? So what is the J in torsion? Which is nothing but polar moment of inertia of shaft. In the same way, here J is nothing but polar moment of inertia of the spring wire. Ardhamavutunda? Anduvalla D is nothing but diameter of the wire. Antegani diameter of the coil kaadu. If you substitute 80, it will become, you are going to do mistake. Okay. So ikkada J anedi polar moment of inertia of the wire kabatti, aa wire yokka dia manam teeskovali, which is 10. Substitute and tell me what is the shear stress due to torsion?
40.743 Newton per mm.
40.743. What is the unit, amma? Newton per
mm square.
Right. Next, in the same way, let's calculate what is the shear stress due to axial tension. Axial tension valla generate aina shear stress enta. Okay. So let me take this as tau 1, tau 2 తీసుకుందాం. Okay. So what is the shear stress due to tension?
Sir, doubt, sir.
చెప్పండి అమ్మా.
Sir, ikkada paina equation lo R cancel kada, sir.
R cancel కాదమ్మా. R ను మీరు 2 times of D గా రాయండి.
Yes, sir.
Okay. Right. J also write in terms of dia. Okay, then you will get the dia. Dia cancel avadu kada. Understood?
Okay, sir.
Right? Okay. So that's how you can able to calculate the torsional shear stress. Now, axial tension, you need to calculate the shear stress. Represent that in tau 2 form. So what is the axial shear stress formula? Okay, stress formula enti? Stress is equal to load by area. Why I am writing stress is equal to load by area? Because it is an axial tension kabatti. Right? Avuna? Axial tension kabatti, the stress formula is load by area. Okay. So represent the same here. load W. What is the area of the wire? What is cross sectional area of the wire, amma? Intena 4W by pi d square. 4 into what is load, amma? 200 pi into what is d? 10 square. Enta? What is tau 2? How much is tau 2?
2.546.
2.546 Newton per mm square. ఇక్కడ వరకు అందరికి అర్థమైందా what I have done here? Okay, see here, if you take any spring, springs will have two kind of stresses. One is torsional shear stress, other one is axial shear stress. Axial ante it might be either tension or it might be either compression. Okay, so that's why two stresses we have calculated based on the stress equations. Torsional stress equation enti T by J is equal to tau by R. Normal shear stress యొక్క equation enti stress is equal to load by area. So based on these two relations, so based on these two formulas, we have calculated shear stress due to torsion, shear stress due to axial tension. Okay, so now what I'm going to do, I'm going to sum these two to calculate the maximum shear stress which is developed due to both torsion and tension. Okay, let me write that. Total shear stress, which I consider it as a maximum shear stress, is equal to tau 1 plus tau 2. What is tau 1? Torsional plus tensile shear stress. What is this value? 40.74 plus 2.54 amma. Okay, tell me total.
43.289.
43.3 we can consider it as. Okay, 43.3 Newton per mm square is the maximum shear stress which is developed in the spring due to both torsion and tension. Right now, ఏం క్యాలిక్యులేట్ చేయమన్నారు మనల్ని? He asked you to calculate two things. First one, deflection. Delta. What is delta formula? R into theta. Right? So what is the delta formula? R into theta represent cheyochu 64 W R cube into N by N d power 4. Substitute all the values. What is radius amma? What is R here? What is R? See, you have
Radius of coil
enta
40, sir.
right. How many turns? 10. What is modulus of rigidity? Right. Now calculate and tell me the answer. What is the deflection? Fast ga. What is the deflection? See, you have to use your calculus while doing problems. Okay.
9.752, sir.
9.752. Good. Okay, so this is how we can able to calculate the deflection. And the next one, energy stored in the body. Energy stored. How to calculate energy stored, Amma? As a spring, the energy stored is half into what? W into delta. ఎలా వచ్చింది ఇది? So this is what an energy stored. Okay, so it can be represented half into W into delta. చెప్పండి ఎంత? Half into 200 into what is delta, Amma? How much?
975.26.
Unit. See, units kuda cheppallamma. Newton into mm. Why? Because load is in Newton, delta is in mm. Then ela raichu? Raicha? Yes or no?
Yes, sir.
Right. Then
Sir,
inko
doubt.
vidhanga raichu elaga? Can anyone? Newton into meter can also be called as. మీరందరూ strength of metals లో చార్పి టెస్ట్ చేశారా? There on the dial gauge it was clearly mentioned what is 1 Newton into meter. It can also be represented as joule. 1 Newton into meter is equal to 1 joule అని అర్థం. ఓకే, ఎందుకంటే ఇవే ఇంపార్టెంట్ అమ్మా కాంపిటేటివ్ ఎగ్జామ్స్లో. ఏదో మీరు ఆన్సర్ getting answer is very easy, but representing answer based on the option is challenging. Okay, so because there will be an answer with 975 Newton into mm, there will be an answer with 0.975 joules. Okay, when they ask you to represent in a form of a joule, you have to represent that. Okay, 0.975 joule, ఎందుకంటే 1 Newton meter అన్న ఒక joule అన్న ఒకటే. Clear? Right. So this is what about a closed coil helical spin.
సార్
చెప్పండి అమ్మా.
సార్ ఇక్కడ ఎనర్జీ స్టోర్డ్ అంటే స్ట్రెయిన్ ఎనర్జీ స్టోర్డ్ కదా సార్?
అంతమ్మా, strain energy stored for the spring.
ఎస్ సార్, మనం ఇంతకు ముందు టార్షనల్ స్ట్రెయిన్ ఎనర్జీ అండ్ యాక్సియల్ ఫోర్స్ స్ట్రెయిన్ ఎనర్జీ చేసాం కదా సార్?
అదేమ్మా, టార్షనల్ స్ట్రెయిన్ ఎనర్జీని మనం కన్సిడర్ చేసాం. వాట్ ఇస్ ద టార్షనల్ స్ట్రెయిన్ ఎనర్జీ? హాఫ్ ఇంటూ టీ ఇంటూ theta. Okay, so this can also be equal to half into W into delta. అవునా?
Yes sir.
Right. So మనం ఇది యూజ్ చేసాం. If you want to use this, you can use this with respect to torsion, with respect to theta. అర్థమవుతుందా?
Yes sir.
You will get the same values. ఎందుకు? This strain energy is due to what? Axial.
Axial.
This strain energy is due to what?
Torsion.
అంతే. Both are equal. మీరు కావాలంటే అలా కూడా ట్రై క్యాలిక్యులేట్ చేసి చూడండి. యూ విల్ గెట్ ద సేమ్ ఆన్సర్ ఆల్మోస్ట్. ఓకే, చేస్తారా అది కూడా? లెట్స్ డూ దట్. యాజ్ యూ ఆస్క్డ్, డూ ద సేమ్ and calculate what is strain energy stored in a body due to torsion. Strain energy stored in the body due to torsion. చేయండి అమ్మా ఇది కూడా. At least you will come to know what is torque అమ్మా. మన టార్షన్ వాల్యూ ఎంత?
8,000 sir.
వెరీ గుడ్. ఇంటూ టీటా. టీటా క్యాలిక్యులేట్ చేయాలి కదా. వాట్ ఈస్ టీటా ఫార్ములా? ఇందాక ఫార్ములాస్ అన్ని రాసాం కదా. టెల్ మీ వాట్ ఈస్ టీటా ఫార్ములా? 64 WR by ND power 4. Yes? 64. What is W? 200. What is radius of the coil? What is turns? 10.84 into 10 power 5 into d ఎంతమ్మా 10 power 4.
Sir, radius 40 mm, sir.
ఎంతమ్మా
40 mm, sir, radius.
Oh, sorry. Diameter 80 కదా, yeah, radius 40. 40. Yeah. చెప్పండి. What is theta? Tell me your angle with respect to radians. ఎందుకంటే మనకు ఆన్సర్ వచ్చేది రేడియన్స్ లో వస్తుంది. ఎంత ఇది? Tell me what is the answer of strain energy stored in the body due to torsion. What is angle of twist? Enta 64 into 200 into 40 square into 10 by 0.84 into 10 power 5 into 10 power 4.
0.243, sir.
0.243 radians amma. Okay. So substitute here. Answer ఎంత చెప్పండి?
$972, sir.
972 unit.
Newton mm, sir.
Right. దీన్ని ఎలా రాయొచ్చు? ఇందాక మీకు వచ్చిన ఆన్సర్ ఈ ఆన్సర్ సేమా?
0.975 అది వచ్చింది, sir. ఇది 0.97.
So that means both are same, right? Isn't it? Yeah. See, torsional strain energy stored in a body aina, axial strain energy stored in a body aina. So both are same. Okay. When the springs are subjected to load. Okay. So అందువల్ల మీరు ఏ ఎనర్జీ అయినా మీరు క్యాలిక్యులేట్ చేయొచ్చు. ఓకే, చూడండి మీరు క్రాస్ చెక్ చేస్తే కూడా మీకు సేమ్ వచ్చింది. సో బై దట్ దిస్ ఇస్ హౌ వీ కెన్ కంక్లూడ్ అవర్ అప్లికేషన్స్ అన్నమాట. ఓకే, సో టార్షనల్ అయినా అదే ఎనర్జీ స్టోర్ చేసుకుంటుంది, ఈవెన్ యాక్సియల్ లోడ్ అయినా కూడా అదే ఎనర్జీ స్టోర్ చేసుకుంటుంది ఆ పర్టికులర్ స్ప్రింగ్. క్లియర్? ఫైనా? ఏమో అందరు నోట్ చేసుకున్నారా? అందరికి అర్థమైందా?
Yes, sir.
Closed coil helical spring and what are the formulas which we derived from that, and how to solve the problem and all. Okay, so now so let me give a glance on in the next class what we are going to discuss. So there are few more topics to be discussed. Our topics into cheptanu. So in the next class we are going to cover all this and we are going to close the springs. Okay, so next one is open coiled helical spring discuss chestamu, and we are going to write down the deflection formulas of a open coiled helical spring. Okay, and next one we are going to write the deflection formula for leaf spring, right? And the next topic is on springs which are connected in so because tomorrow we are having class, right? Springs in series, and next one springs in parallel. Okay, so open coiled helical spring ante your spring will be open like this. Okay, it is not closed loop anamata, it is an open loop. Leaf springs, so which are all bending plates. Okay, so like this leaf springs will be there. How to do the deflection formula for these two ane chustam. And springs in series, what do you mean springs in series? When the springs are connected like this. Okay, so this is called a series connection anamata. Okay, springs in parallel ante One spring will be here, the other spring will be here. So both are subjected to load W. So this is called parallel. Okay. So like this, we are going to discuss these 4 topics. Okay. So in this way, we are going to discuss these 4 topics in the springs and we are going to conclude. Okay. Right. So see you in the next class. So please go through all these topics again. Right. So by that we can end up the springs easily. Okay. In the first unit, chala peddadamma, you are having 3 topics. One is torsion, the other one is springs, and the next one is curved beams. So immediately we have to start curved beams. So by that next units chala fast ga complete hotai. Endukante they are very easy. First unit koddiga lengthy anamata. Okay. So but still we will go slowly. I want to make every student to understand. Okay, that is my goal ante. Okay. If you want, we can take extra classes and we can finish the classes. Okay, no issue. But meeku ardhamavutundha ledane naaku chaala important. Okay, right. So please go through. I will gonna upload these 2 videos in YouTube today itself. Okay, na? Right. Bye, amma. Any doubts na everkaina? Guys, any doubts? Clear? Okay, so then see you in the next class. Okay.